Hello everyone, welcome to this video on methods of solving Lagrange's linear equation. So in which we are going to see how to solve a Lagrange's linear equation. So first let us see what is a Lagrange's linear equation. So a linear PDE of the first order of the form PP plus QQ is equal to R is called the Lagrange's linear equation where capital P, capital Q and capital R all are functions of x, y, z. And this equation can be solved using the following steps. For first we have to write the auxiliary equations. So which are written as dx by capital P is equal to dy by capital Q is equal to dz by capital R. So solving these auxiliary equations, we can get the two independent solutions, say u is equal to a and b is equal to b. And finally, we are writing the general solution as in this form. It is f of u comma v is equal to 0 or u is equal to f of v, or that may be written in this form v is equal to f of u. So now let's see how to solve these auxiliary equations. So solving the auxiliary equations can be done using any one of the method. The first one is known as method of grouping. So in which we are just equating the pairs of fractions from the auxiliary equations and integrating them, we can find out the two independent solutions. The second method is called method of multipliers. In this method, we choose some multipliers. In this method, we choose some multipliers, say L comma M comma N, and these multipliers can be constants or functions of x, y, z. Okay, so we are choosing the multipliers in such a way that L into capital P plus M into capital Q plus N into capital R is equal to 0. So when you choose your multipliers in this way, we can say the numerator term, that is L into dx plus M into dy plus N into dz, can be equated to 0, and then integrating that equation we can find one of the solution, and by choosing different multipliers, by applying the same procedure, we can find our second solution. So now let's see some examples for solving a Lagrange's linear equation. So in which we are going to apply both method of grouping and method of multipliers. So this is what our first example, that is px plus qy is equal to z. So we have to find the general solution of this equation. So first step is, let us name the equation as 1. So first we are going to write the auxiliary equations of the given. So the auxiliary equations are written as dx by p is equal to dy by capital Q is equal to dz by capital R. So in place of capital P we have this, in place of capital Q we have this, and in place of R we have this, because this is in the form of capital P into small p plus capital Q into small q is equal to capital R. So this form of first order linear PDE is known as Lagrange's linear PDE. So now we have written the auxiliary equations. So now we are just going to replace capital P, Q and R in this. So which gives our auxiliary equations here, that are dx by x is equal to dy by y is equal to dz by z. So what method can we apply here? So just when you look at these ratios, it is easy to eliminate, or it is easy to find out the solution using method of grouping. So here we no need to choose multipliers. So directly just by grouping method we can obtain the solution. For I'm going to consider the first two ratios. So considering the first two ratios and integrating them, what I'm getting, dx by x is equal to integral dy by y, which is nothing but log x is equal to log y, plus that constant can be taken as log u. So from this we get x is equal to, that is log x is equal to log y into u from this. So when you cancel this log term, either side you get x is equal to y into u, that is from this we get one of our solution u as x by y. So similarly, if you consider the second and third ratios, that is second and third ratios, we can obtain another independent solution, that is taking dy by y and dz by z and integrating them, we get log y is equal to log z, plus that constant can be taken as log v. So from this we get y is equal to z into v. From this, our second solution v is nothing but equal to y by z. So we got two solutions. So finally we can write the general solution as f of u comma v is equal to 0 in this form. That is f of x by y comma y by z is equal to 0. So this is what our second example. So this also in that Lagrange's form. Okay, so in place of capital P we have this, in place of capital Q we have this, and in place of R we have this. So let us name the given equation as 1. So first we are writing the auxiliary equations. So the auxiliary equations are dx by capital P, that is dx by y square z by x, and dy by x into z, and dz by y square. Okay, so here also we can apply the grouping method. Okay, so using grouping method, considering the first two ratios. Okay, so here I can cancel this z. So I'm having here, I can take this x to the numerator, and here I'm having one more x. I'm taking this x to the left hand side. So I'm getting x square into dx as my left hand side, and taking this y square to the right hand side, I'm getting my right hand side as y square into dy. Now I'm going for integration of this, so which gives x cube by 3, and this one is y cube by 3, and the constant can be taken as some c. So from this I'm getting x cube minus y cube by 3 is equal to c, and from this I can write x cube minus y cube as 3c. That can be taken our first solution u. So this is what our first solution. So now to find the second solution, I'm going to consider the first and the third ratio, because in the first I'm having y square in the denominator. Similarly, in the third also I'm having y square in the denominator. So I'm going to take first and third ratio for finding my next solution. That is dx by y square z by x. This is my first ratio, and my last ratio is dz by y square. So now I can cancel this y square term, and taking this x to the numerator, it is x into dx. This is equal to, and taking this z to the right side, I'm having z into dz as my right hand side. So now I can go for the integration. So now integrating this, I'm getting x square by 2 is equal to z square by 2 plus some d. So from this I'm getting x square minus z square by 2 is equal to d, and x square minus z square is 2d, and this can be taken as my second solution v. So now I got my two independent solutions, so I can give my general solution as in this form: f of u comma v is equal to 0, which is nothing but f of x cube minus y cube comma x squared minus z square is equal to 0. So now we'll see one more example in this. So this is what our given equation. This is also in the form of Lagrange's linear equation. So in place of capital P we have this, in place of capital Q we have this, and in place of R we have this. So we have Lagrange's form of linear PDE. Capital P into small p plus capital Q into small q is equal to capital R. So our first step is we have to write the auxiliary equations. So the auxiliary equations are dx by capital P, that is mz minus ny, and dy by capital Q, that are nx minus lz, and the third term is dz by capital R, that is ly minus mx. Here there is no way to find out the solution by the method of grouping, because in every term, that is if you look at the denominator terms, so in the first I'm having two variables, say z and y, but the numerator is x. And like that in the second term, the denominator I'm having two variables x and z. So here it is not easy to apply method of grouping, so I can go for multipliers method. So how I'm going to choose my multipliers in order to make the denominator 0 here. So in the first, if I'm first, yeah, L is missing, and in the second M is missing, and in the third N is missing. So I can choose my multipliers as L for the first term, M for the second, and N for the third term. And I'm going to multiply both numerator and denominator by it, and then I'm going to add all the three terms. Okay, all the three ratios, and I can say these three ratios are equal to that LDX plus MDY plus NDZ. So in the denominator also I'm multiplying the first one by L. So it is LMZ minus LNY. Second term is multiplied by M. So it is MNX minus MLZ. And third term is multiplied by N. So it is NLY minus MNX. So now when you look at the denominator, the sum gives 0. Okay, so which means what? If we can equate this is equal to this, means I can say this is equal to some constant. So all are equal means I can say this is equal to some constant. Say k. Okay, since the denominator is 0, when you take this denominator to the right hand side, so you can say the numerator is 0. So from this what I can say, if you can make the denominator 0, then you can say that the numerator is 0 here. So numerator is 0. So now integrating this, I'm getting my solution as Lx plus My plus Nez is equal to U. So this is one of the solution. So here I'm taking my constant in the left hand side and taking that to the other side and renaming the constant, I can write it as U. Okay. So how can I choose different multipliers in order to get different solution as my second one? For what multipliers I can choose? So here I can choose my second multipliers as x, y and z. Okay. So if I choose the multipliers as, here I have chosen the multipliers as L, M and N. Like that I can choose my multipliers as x, y and z. So if I choose my multipliers in a similar way, if I apply the procedure by choosing the multipliers, I can say x dx plus y dy plus z dz is equal to 0. Because when you multiply the first one by x, second one by y and third one by z, you will get the denominator, the sum of the denominator is what? 0. So I can say the numerator. At the same time, we are multiplying the numerator term. The first one by x, second by y, and third one by z. So in place of L, M, in place of L, M, N, if you just replace by x, y, z, we get this. So now I'm going for integration. So when you integrate this, I'm getting the answer as x square plus 2 plus y square by 2 plus z square by 2 plus some constant d is equal to 0, taking this d to the other side, and you can rename it and you can take it as your second solution v. Okay, that is, it is nothing but 2d, right? The 2d minus 2d can be taken as from this. The second solution is x square plus y square plus z square is equal to minus 2d, that can be taken as our second solution v. So now I can write our general solution as f of Lx plus My plus Nez comma x squared plus y squared plus z square is equal to 0. Hope you understand these concepts. Thank you for watching.